Understanding polynomial expressions. Okay, the objectives is identifying monomials, classifying polynomials, and identifying like terms, simplifying polynomials, and evaluating the polynomial. So first, we have to know what's the meaning of polynomials. Poly here means many. So poly means many. In this case, nomials means terms. So polynomials means many terms. Many terms. We're talking about many terms. Okay? A polynomial can have constant, like 3, -10, -20, a half, whatever, any number. Constant means any number. And variables like x, y, and so on, z, whatever. Exponents, and exponents here should be on the variable, like y power 2. In polynomials, I can only have exponents with a whole number, like for starting from 0, 1, 2, 3, and so on. It cannot be fraction, or it cannot be decimal, or it cannot be negative number. Okay? Here are the exponents. Any term can consist either of constant only, or variable only, or variable with exponents, or the three of them together. Okay? The variable here cannot be in the denominator. If it's in the denominator, so it's not a polynomial. Okay? So in the polynomial, you cannot have a variable in the denominator. Okay, how to identify monomial? Monomial is, we said, it consists of one term. A monomial means one term. So we said that the term can be variable, a product of a number and a variable with an exponent. So a variable, a constant, a variable, and a power or an exponent. This is a term. So example here, we can have -3x power 3. I have a constant, variable, and a power of a variable. I can have here 2x power 3 y, and this is only one term because what's between them is only multiplication. If I have 2x power 3 y, it means 2 times x power 3 times y. So it's only one term. Okay? If I'm talking about multiplying and division, so we're still in the same term. What separates the terms is plus or minus. So when we see plus or minus, that means we're starting another term. X, for example, is a term. 6 is a term. It's only a constant, so it's a term. -12x, also a term. Classifying polynomials. So polynomials is my umbrella that I have under it. The other things like 3x squared, it's only one term, so we can call it monomial. Monomial. 3x power 2, it's only one term, so I call it monomial. 3x plus 4y, here my separation is the plus, so I have here two terms, 1 and 2, so it's binomial. Okay, if I have here, how many separation I have here and here, so 1, 2, 3, so it's three terms, trinomial. And all of these are under polynomials, because polynomials can be a monomial or a sum of monomials or whatever. So as we said before, polynomials can have more than one term, or it can only have. What's not a polynomial and what's a polynomial? Here, 5xy power 2, it's a term, normal term. -3x, another term. +5y power 3, a term. -3. All these terms can be a polynomial. Okay? But here, these are not acceptable. 3xy power -2. I cannot have a negative in the power of the variable. The power of the variable cannot be a negative. That's why it's not a polynomial. And here my problem is that I have a variable in the denominator. We said we cannot have a variable in the denominator. Okay, so these are not a polynomial. Example of monomials and not monomials. Here, this 4 is a monomial, it's a constant. X, it's a variable alone, so it's one term monomial. Negative 4xy, xy, yes, they are two variables, yes, I know, but they are multiply each other, so it's just a monomial. 0.25 x power 3, yes, I have here a decimal, but it doesn't matter. A constant can be any number, fraction or decimal, and x power 3, so it is a monomial. Xy over 4, I don't mind to have a number in the denominator. My issue is to have a variable in the denominator, but here xy over 4, it's a normal polynomial, which is a monomial. Okay, not a monomial. I have here 4 plus x. 4 plus x. Why it's not a monomial? It's two normal terms, so it is a polynomial, but it's not a monomial. So it's a polynomial, but it's not a monomial. So I have 4 and x, so it's a binomial, but it's not a monomial. So x minus 1, it's the same thing. I have two terms, x minus 1, so it's a binomial, but it's not a monomial. 0.7 x power negative 2. The problem here is not the 0.7. 0.7 it's fine. The problem here is the power negative. We said that the variable cannot have a negative power, so it's not even a polynomial. 0.25 x power negative 1, it's the same issue. I cannot have a negative power for the variable. Y over x power 3, I said before I cannot have a variable in the denominator. So that's why it's not even a polynomial. The degree of a polynomial. The degree of a polynomial is the greatest value among the sum of the exponents on the variables in each term. Only the variables. So, for example here, negative 3, x power 3. What do I have here? X power 3. X power 3, the variable here has a power 3, so it's the third degree. It's the third degree. Okay? I only take the power of the variable. Here, negative 12x. I don't have a power for this variable, right? So I should write 1. I should write 1. So it's negative 12x power 1. Okay? X power 1. So the degree here will be the first degree, because I only see the power of the variable. As for this one, 2x power 3 y. I have two variables, so I have to get the sum of the exponents. So 3, and what's the variable of the, what's the power of the y here? Yes, it's 1. So it's 3 plus 1. So it's 4. So it's the fourth degree. As for the 6, do I have a variable here? No, I don't have a variable. So any constant with no variable, it means it has an x with power 0, or any variable with power 0. So because we said before, anything with power 0 is 1. So here it's 0 degree, or it has no degree. So any constant has 0 degree. The degree of a polynomial is the greatest value among the sum of the exponents on the variables in each term. So example here I have, find the degree of the following polynomial. 8xy power 2 minus 5x power 3, y power 3, and z. The first thing I should do, check the powers of the variables. I have here x, it has no power, so it's 1. Here z, it has no power, so it's 1. Then 8x power 1, y power 2 will be the 1 and the 2 together. 1 plus 2 will give me 3. And the other term, 5x power 3 y power 3 z, put the 1, so it will be 3 plus 1 equals 7. Who's bigger? I'm gonna check. Here it has 3, the degree is 3, and here the degree is 7. The polynomial will take the degree of the biggest one, or the highest degree. So here I will take the 7. So the degree of the polynomial will be 7. Find the degree for the following polynomials. Let's work it out. So I have here 7x power 2 minus 5x power 3 y power 3. Okay, so I'm gonna see here. Here I have 2, and here 3 plus 3, which is 6. Who's bigger? Yes, the 6. So it's the degree is gonna be 6. Here 3 power 2, I don't care because it has no variable, so it means the degree is 0. Remember, I don't care about this 2 because this 2 is the power of the 3, not the power of the variable. And here 2n power 3, so it's 3. And here 8 power n power have nothing, so it means 1. So whose highest degree? Yes, it's the 3. So the degree here will be 3. The standard form. How to put the polynomial in the standard form? Standard form of polynomial containing only one variable is written with the terms in order of descending degree. What does that mean? Here, I cannot put any polynomial in the standard form. I only put the standard form of the polynomials that having the same variable, like this one. 5x power 4 plus 4x power 2 plus x minus 2. This is the standard form because I put the terms in the order of descending degree. So here the highest degree, which is x power 4, x power 2, x, and negative 2, which is a constant, or x power 0. Okay? So, and when I put it in the standard degree, it's going to be very easy for me to pick up the degree of this term. When I put it in the standard form, it's easy for me to pick the degree because it's going to be the first power, okay, the first term's variable power. So it's going to be 4, okay? So the degree is the 4th degree. I have something called the leading coefficient. You have to know very well that each number beside a variable in each term is called a coefficient. So here, the 4 is the coefficient of x power 2. Sorry, 4 is the coefficient of x power 2. 1 here is a coefficient of x. And 5 here is the coefficient of x power 4. And I have something called the leading coefficient, which is going to be the coefficient of the variable which has the highest power. It's going to be the leading coefficient, and that's going to be the 5 here. Okay. Write each polynomial in standard form and find the leading coefficient. Okay, so here 20x minus 4x power 3 plus 1 minus 2x power 2. Okay, so first I'll see the degrees. Here x power 1 degree is 1, x power 3 degree is 3, plus 1, so it's 0 degree, and x power 2, so it's 2. Then put them in order. So the highest will be the negative 4x power 3, then negative 2x power 2 plus 20x plus 1. And the leading coefficient here will be the negative 4 because it's the coefficient of the highest power of a variable. The next one, z power 3 minus z power 6 plus 4z. I'll have here, the first one is 3, the second one degree is 6, and the last one is 1. So put them in order. Descending order, yes. So it's going to be negative z power 6 plus z power 3 plus 4z. Put them in order. Yes, very good. Then the leading coefficient is negative 1. Identifying like terms. The like terms are the terms that having the same variable with the same with different powers. No, with same powers. Yes, very good. So same variables and same powers. It cannot be different powers. So r power 2, 5r power 3, and 2r power 2. Are these the same? No, because they have same variable but different powers. We should have same powers. So r power 2 and 2r power 2. These are like terms and these are unlike terms. So the terms having the same variable with the same power. Like, let's identify here the like terms. 3t, 5w power 2, 7t, 9v, 4w power 2, 8v. So I have 3t and 7t. They both have t. Here, w power 2 and 4w power 2, they both have w power 2. And here, 9v and 8v. So these are the like terms. So let's simplify the like terms. We can combine them together. How is that? I just add up or subtract the constant and leave the variable as it is. So negative 2y power 3, negative 8y power 2, plus y power 2, plus 2y power 3. So the first thing I should do is identify the like terms. I have here the y power 3, don't forget to take the sign with you, and the 2y power 3. I have here negative 8y power 2 and y power 2. So put them beside each other and let's start. Negative 2y power 3 plus 2y power 3. So negative 2 plus 2 is 0. So these two will cancel each other. The negative 8y power 2 plus y power 2 will be y power 3. Here we said it's going to be 0 and negative 8 plus 1 will be negative 7. And the variable here is y power 2, the variable here is y power 3. 0 plus y power 3 will be 0, and here negative 7 times y power 2 will be negative 7 y power 2. The next one, p power 2 q power 3 minus 4 p power 5 q power 4 negative 4 p power 2 q power 3 plus 3p power 5 q power 4. Let's see. Here I have p power 2 q power 3, so I have this one and this one are the same, and this one and this one are the same. Let's put them beside each other. And let's start. Negative 4 p power 5 q power 4 and 3 positive 3 p power 5 q power 4. Negative 4 and positive 3, and here this p power 2 q power 3 and negative 4 p power 2 q power 3. Negative 4 plus 3 will give me the negative 1, and 1 negative 4 will give me negative 3. So negative 1 times p power 5 p power q will be negative p power 5 q power 4 and here will be negative 3 p power 2 q power 3. So I'm just combining the like terms by adding or subtracting the constants or the numbers beside the variables and keep the variables as. How to evaluate the polynomials? Evaluating the polynomials, it means that putting a value for the variable and then evaluate the whole expression. So a skyrocket is launched from 6-foot high platform with an initial speed of 200 feet per second. The polynomial is negative 16t. Here I have the polynomial, negative 16 t power 2 plus 200t plus 6 gives the height in feet that the skyrocket will rise in t seconds. How high will the rocket rise if it has 5-second queues? So he gave me already the t, so I just have to substitute the t with 5 seconds. So I'll take away each t and put instead the 5. So negative 16, 5 power 2 plus 205 times 5 plus 6 will give me 16. 5 power 2 is 25 plus 200 times 5 plus 6 will give me negative 400 plus 1000 plus 6. So add them up together, it will give me 606. Another example. Lisa wants to measure the depth of an empty well. She drops a ball from a height of 3 feet into the well and measures how long it takes the ball to hit the bottom of the well. She uses a stopwatch starting when she lets go of the ball and ending when she hears the ball hit the bottom of the well. The polynomial we're using here is negative 16 t power 2 plus 0t plus 3 gives the height of the ball after t seconds, where 0 initial speed of the ball and 3 in the initial height the ball was dropped from. Her stopwatch measures time 2.2. Okay, you have to know very well that this is just a story to give you the problem, but all what we need here is the polynomial itself, okay, the polynomial itself, and the number of that we're gonna substitute with which is this times in seconds. Let's do it. Negative 16t power 2 plus 0t plus 3. Then take away the t and put instead of 2.2 power 2 plus 3. So 2.2 power 2 will be 4.84. We will multiply it by the 16, will give me negative 74.44 plus the 3. So 74.44 is after we added the 3. Okay, so the ball goes 74.44 feet below the ground. The well is 74.44 feet deep. And that's it for our lesson for today.